Okay. Okay, can see the slide?
Yes.
Can Hey, so let's continue what we did yesterday. I just introduced you with what is ultrasound. Okay, so we introduced the beginning part where it's used for shape and it's used for check the fetus development and yeah. So now we're going to talk about the process, how it works. Okay, so we're going to start with the transducer. Okay, so the transducer. Okay, the transducer is actually made of electric field. It's electric field. So you apply alternating voltage. In between the electric field kept with the crystal. There is a crystal, silicon oxide crystal. When you apply the voltage, alternating voltage, the silicon oxide will start to oscillate. Okay, oscillate. Resonance will happen and produces ultrasound. Okay. So yeah, so it just see the highlighted one, the green and yellow. Okay. The transducer probe is main part of the ultrasound machine. Makes the sound wave and receive echoes. Yeah, you got two jobs. E is the one produce the sound. At the same time, E going to be the receiver later. Okay, the piezoelectric effect. So it made of crystals. When a potential difference is applied, the crystal will change shape rapidly, produce the sound wave. Okay, so electric signal produce sound. Then later, when the sound reflected from the boundary reached the transducer back, now the other one happened. Conversely, the other way around. When the sound or pressure wave hits the crystal, they emit electrical pulse. It produces electric pulse again. Okay. Yeah. So that's the two opposite movement. First sound create. First electric create the sound, then sound create the electric back. Okay. The functional receiver. So yeah, so same crystal send and receive the sound wave. The probe also has a sound absorbing substance. It's, as I said, made of silicon oxide, piezoelectric transducer, piece of quartz crystal, two opposite sides coated with thin layer of silver. So the silicon oxide is in a tetrahedron shape. So bottom center silicon is positively charged, covered with 4 oxygens. Okay, oxygens at the bottom is more negative. Although it's neutral, the bottom part looks like more negative. It's more negative. Top is like more positive. Quartz is made of a large number of repeating tetrahedral silicate units. Tetrahedral units. The position of the oxygen links are not rigidly fixed. Yeah. If you give a little oxygen, negatively charged, movement can be encouraged by applying electric field. Give a little electric field, they can vibrate. So this is how you see this is the crystal. When you apply a potential difference, up let's say negative, down is positive, silicon will pulled up. At the same time, all the oxygen will pull down. What happened? So as I said, the bottom part is more negative. So the crystal will in an extended state, will be extended. Okay, the crystal will be extended. Oxygen all move down, silicon move up. Okay, extended. So when unstressed, nothing happened. When you give a positive on top, the silicon will move down, the oxygen will move up, crystal will be under compression state, will be compressed. Okay. When the crystal is unstressed, the center of the charge of the positive and negative ions bond lattice is so their effect are neutralized. The constant voltage is applied, the positive silicon ions are attracted towards the cathode, the negative oxygen ions towards the anode. This causes distortion of silicate unit, and depending on the polarity. If this alternating current was applied at a very high frequency in an ultra frequency region, ultrasound region, more than 20,000 hertz. So the crystal will oscillate and produces ultrasound. Okay. An alternating voltage applied will set up a mechanical vibration. The frequency of the applied voltage same as the natural frequency of vibration of the crystal. The resonance of this. So it's one application of resonance. And the natural frequency for the crystal is found to be under ultrasound region. The dimension of the crystal can be such that the oscillation are in an ultrasonic range more than 20 kilohertz, thus producing ultrasound. Okay, the alternating signal is applied to the piezoelectric transistor. The crystal oscillates. Okay, the frequency of the piezoelectric transistor set to the natural frequency of the crystal. So crystal resonance happens. Crystal will emit ultrasound more than 20 kilohertz. As I said, normally they use 100 kilohertz, if I'm not mistaken, for the ultrasound. Okay, the ultrasonic transistor can also be used as a receiver. Later used as a receiver. When the ultrasonic waves incident on the piezoelectric crystal, the pressure variation alter the position of the positive and negative ions within the crystal. Yeah. So when the sound goes in, now the sound which has a pressure going to exert a pressure on the crystal going to start to vibrate. When they oscillate, what happened when silicon move more up? Sorry, extended. So extended, they give a different polarity. Okay, when compressed, they give a different polarity. The voltage up and down going to be different. So it create a alternating signal back. Okay, alternating signal back. So the alternating signal will have a frequency same as the oscillation of this crystal. Okay. This varies. Yeah. This induces opposite charge on the silver electrode, producing a potential difference between the two. Yeah. Look at the second point. When the ultrasonic waves incident on the piezoelectric crystal, the pressure variation alter the position. Okay, this induces the opposite charge on the silver electrode, produce a potential difference. This varying potential difference can be amplified and processed. Yeah, transducer alone cannot. The signal is very weak, so the signal need to be sent to the, of course, op-amp to amplify it. Okay. So what type of op-amp you use here? Comparator or feedback? Use what do you call feedback? Use the feedback so that because the signal pattern we need to retain but enlarged. Okay. Okay, so this is one animation tells the simple idea how the ultrasound imaging is produced. So when the ultrasound get into the, what do you call, sent to the body, this is every border of body now. Means soft tissue, then reach maybe another part of the body, maybe bone. After bone, you have another tissue. So this is the boundary of two different tissue. What happened? The ultrasound would be partially reflected, partially transmitted. Okay. The transducer will get back the reflected signal. Okay, so we create the images. So ultrasound imaging is performed in emitting a pulse, which is partly reflected from a boundary between the two tissue structures, and partially transmitted. Partially will be transmitted. Okay. The reflection depends on the difference in impedance of the two tissues. Yeah, something called impedance we will learn later. How much will be reflected, how much will be transmitted, it depends to some resistance effect called impedance of the tissue. Impedance determines how much will be reflected. Class, just 1 minute. Hello. Okay. Okay. Sorry. Give me 5 minutes. I just fetch my son and come back. Okay. Sorry. Give 5 minutes. Take a break.